folks. All right, so I know Joel gave a brief introduction, but briefly about myself, I'm a senior product manager at Pluralsight. Now, Pluralsight is a company based out of Utah, and they have an office in Boston as well. And there's a fun little story about the name of the company, which I won't get into. But the brief version is that at the time when our CEOs were founding the company, which was back in 2004, they were inspired by, these names which were sort of two syllables, and like Microsoft is one of them. So they actually wrote a program to come up with a name, and that program came up with this name called Pluralsight. So that's a fun little story about the name. Anyway, so about myself, I've been working in the digital transformation kind of space for about 9 years now. And my first job was as a professional services consultant, where I was implementing these large-scale ERP solutions for a range of, a number of manufacturing companies. And this was kind of back in 2007 when cloud, had not yet taken off. And this was also back in India, where a lot of our customers were sort of moving from the metaphorical pen and paper over to these modern ERP solutions. And then in the past 4 or 5 years or so, I've been working with the machine learning and AI products. And I was at Oracle Adaptive Intelligent Applications team, which was building a number of AI and ML solutions for ERP, HCM, financial space. And then in 2018, I got the opportunity to join Pluralsight, and I was asked to kind of help build out our machine learning and AI platform, which has the name of Iris, and to also help scale its applications across the business. So having worked in a few different kinds of settings, today I wanted to talk about how to cross the AI and ML adoption chasm. But before that, I want to start with a quick anecdote. In 2016, a new painting was unveiled in the Netherlands. Now, this conference is happening in Europe, so in the European time zone at least. So I believe a number of people might recognize this painting. At least its style resembles the famous Dutch artist Rembrandt from the 1700s or the 1600s. I might be getting the date wrong over there. Because this painting resembles a lot of the characteristics of Rembrandt's work. But if you are familiar with his entire history of work, you might actually struggle to pick this one, because it turns out this is not a painting by Rembrandt. This was actually done as a project for the ING group, and also led by the creative ad agency J. Walter Thompson in support with Microsoft. And they had a bunch of AI engineers, machine learning engineers, data scientists, and 3D printing experts kind of create a neural network algorithm which looked at Rembrandt's entire history of work to come up with this painting. The algorithm looked at different characteristics of all of Rembrandt's work. So things like what are the characters in his paintings, what's the dress that they are wearing, what's their gender. Additionally, they also looked at things like the brushstrokes of the paintings to look at how the density of the paint varied across the different paintings to kind of come up with this image, which is of a Caucasian male between the age of 30s and 40s. And here is where I talked about how the painting density varied and how the experts looked at that. So this painting was created almost 350 years after the original artist lived, and this painting was created by AI. Now, why am I telling this anecdote? Because everyone's had their AI moment, right? For some people, it might have been a few years ago when they might have heard of Google, Google's AI beating the Go World champion at the time. For others, it might have been when they might have seen demonstrations of self-driving car capabilities. Like, again, Google has them, Waymo, and then Tesla also has them. For people like me, it's when I look at my Netflix or Amazon Prime recommendations. In fact, sometimes I joke with my wife that these recommendations can be our therapist, because we can look at our recommendations for each other and kind of assess what our mood is for that day, and then determine if we want to continue arguing over whose turn it is to cook today. But these are not the only incidents. You might have also heard of a few cautionary tales of, let's say Amazon a few years ago, they had to scrap their AI in recruiting because it was shown to have bias against women. So when you hear of tales like these, you might think that, oh, looks like companies have figured out AI, but not so soon. In a study conducted by Accenture in 2019, 84% of C-suite executives believe that they must leverage AI to achieve their growth objectives, yet 76% report that they struggle with how to scale. Which kind of makes sense because a lot of times the AI implementations and the AI projects are happening in pockets and in silos, and the entire enterprise is not able to benefit from it. But then when you look at some of the leaders in this field, about 98% of the leaders are actually adopting AI in a number of use cases, and about only 42% of laggards have adopted AI. Now, I'm using the term leaders and laggards, so it makes sense to do a quick refresher of what, where these terms came from. So this came from Jeffrey Moore back in the 1980s, when he came up with this book, Crossing the Chasm, which is, this talk is kind of inspired by that. And he came up with this notion of the technology adoption chasm, where customers adopt new technology in different phases. You have the innovators up first who are actively pursuing the latest technologies. Then you have the early adopters who are just behind the innovators, but these are people or customers who understand these new innovations, and they have a vision for how they can adopt these new innovations at their companies. Then you have the early majority customers that are mainly driven by a sense of practicality. These customers know that a lot of new technologies can be a passing fad, so they wait, for some time before adopting. Then you have the late majority customers that are, that wait for technologies to become a standard before they even go and apply. And then you have the laggards, which are sort of the last to apply any new technology. And this applies to AI and machine learning as well. And you see a similar pattern. The chasm really exists between the early adopters, when you have these siloed projects of a certain technology at your company, to going to the early majority. That's where the chasm exists. And today I'm going to be talking about how to cross that chasm. There are 4 aspects to consider. The first one is business. The second is data. The third is organization structure and org design. And the fourth is skills. So let's get into them. So the first one is business. Now, anytime any enterprise or company starts off with an AI project, it probably is driven by a culture of innovation. You have a forward-looking and a forward-thinking executive who wants to bring AI into their department, and then they get the funding for it. Excuse me. Sorry about that. A little bad throat over there. They get the funding for the project, and then they hire talented data scientists and machine learning engineers. And when they have the team in place, a lot of times the team is just thinking about the technical aspects, about the feasibility of the project. Like having a culture of innovation is great, and you definitely need that for AI projects and machine learning projects, but it also makes sense to make sure that it aligns with your business strategy. Because they say that AI implementation without business strategy is where the rubber meets the air. So the first thing to keep in mind when you're starting off with your AI project is to see, how does it enhance your core competency? How does AI and machine learning enhance your core competency? How does it align with your business strategy? A lot of times your business strategy, you would have to think about who your customers are, what's your core value proposition, and if the AI and machine learning enhances that, that's the best place to start with. But I'm sure you must be wondering, how do I even get started with that? So it makes sense to go back to the first principles and come up with what are the applications of AI and ML, and then what are the use cases under which it can be applied. So broadly speaking, AI and ML applications are, it can be applied to customer experience or operational efficiency. And then when you think of the use cases, there are broadly 3 kinds of use cases where AI and ML is really good. So the first one is the prediction use case, then there is automation, and then there's classification. Prediction is when you have a data set, and then you're making a prediction on what the next set of actions can be. Automation is, when I say automation, I don't mean to imply that AI and ML will replace humans. No, that's not the intent. It's about automating the tasks that are mundane, that are boring, that AI and ML can do really easily. I'm also using the term automation and augmentation interchangeably. A lot of times AI can augment the tasks that humans are doing. And then you have classification. So when you kind of apply that to your business, you can actually construct a matrix like this, for customer experience and operational efficiency, what are the different use cases along prediction, automation, and classification? And this is just a sample set, so let's go through some of them. So if you look at the customer experience application and the prediction use case, you can use that, you can use prediction AI for predicting things like customer churn. And once you have that information, you can use that for creating re-engagement campaigns with your customers. Then another use case can be for next best action, which is, again, like product recommendations or recommending what content to watch next. Then an automation use case can be for onboarding customers to your platform, or even things like chatbots. Then you have classification, which is an example for that can be something like customer segmentation, where you might want to classify your customers along these different segments, and then use that information for different kind of nurturing campaigns or marketing campaigns and whatnot. And then when you look at the operational efficiency applications, a prediction use case can be something like customer support resolution time. Like anytime you're calling let's say your bank or your telephone company, and it says that you are number 5th in the queue, and it'll take about 4 minutes. That's an example of a prediction use case. And then automation, an example of automation use case can be where you might want to automate common workflows that are unique to your business. And through the session, I'll talk about some examples where we are trying to automate some of these workflows at Pluralsight. And then you have the classification example, where an example of that can be something like classifying travel receipts when you're submitting your expense report. The idea for this is not to go after all of these kind of ideas. Rather, this is a generative exercise for you to come up with all the potential different kinds of opportunities or projects or ideas where you can apply AI and ML. And then the next step would be to sort of prioritize which one of those projects or ideas you want to go after. You can come up with a very simple matrix where you can go after the projects that have the highest impact with the lowest effort. And don't be afraid to start with projects like that, because like when I was first hired at Pluralsight, we had a kind of a massive charter to go and build a machine learning platform for the company, an AI platform for the company. But the very first thing that we did was an algorithm, which was not even using machine learning in the sense like it was not a machine learning algorithm per se, but it used the underlying infrastructure that we had built to go after the recommendations use case that we were using it for. So the idea is to identify projects that have the highest impact and the lowest effort. And if you can compute the ROI, I think that's also awesome. So that, in a nutshell, is the things to consider when you're trying to cross the business chasm. Let's look at the next one, data. Now, everyone understands the importance of data, but to get a better sense of the scale and scope of data, here's a kind of a useful reference that Hal Varian, the chief economist at Google, said. 1 billion hours ago was when mankind was first born, when the first Homo sapiens were born. 1 billion seconds ago was when IBM was born. And 1 billion Google searches ago was probably just this morning, That's the amount of data that we are dealing with today. And of course, I don't need to say that Google is the only company that has tons of data. It's just to show that in today's times, data, is generated in massive quantities, and that's what powers AI. So that's another critical factor behind your AI and machine learning algorithms. And broadly speaking, data plays 3 different roles. It's first used for training your machine learning algorithms. You need to get a huge set of labeled data to train your algorithms. Then you apply these training models to the incoming data to make predictions. And then you collect data on these predictions. You're collecting feedback. So as you can see, this data plays a crucial role along the entire kind of workflow of the machine learning pipeline. And when you have to kind of deal with data, there are a few different challenges that you need to think about. The first one is, do you have access to data? A lot of times, companies think that, oh yeah, I do have access to the first-party data, but a lot of times that data would probably be sitting in a different department that might be siloed off, and there probably is not a way to get that data in a continuous flowing form. You also need to consider whether the data is clean and normalized and annotated. which again, like if it's not, then that will affect the accuracy and the precision of your machine learning algorithms. As an example, at Pluralsight, we have a lot of content. Think of like different courses on different skills. So let's say you're looking at all of the courses on JavaScript. Imagine if some of those courses are tagged with JavaScript, which is a single word. Imagine another set of courses that are tagged as Java space script, and few of the courses that are tagged as JS. That's inconsistent. And if we use it in that form, that will affect our recommendations algorithms. And for that, we have to make sure that all of those tags are consistent. The next one is, does the data drift over time? Again, speaking from experience over here, at Pluralsight, we are a skill development company, and we recommend courses on different technologies. And as everyone knows, technology changes very rapidly. So if our models are trained and they are recommending skills from like 5 years ago, that's no good. We have to take into account, these models have to take into account the drift in the data over time. Another example can be if you're using natural language processing that's been trained on data from, let's say, back in the 70s, it probably wouldn't work if you try and apply it to your customer support like chat today, because there are so many words that have come up in the last several decades that this NLP model might not understand. Does the data have any biases? This can be a whole topic in and of itself, but you have to kind of take into account the biases that the data might have. And oftentimes those are biases that humans have that gets captured in the data itself. The Amazon example that I was talking about is kind of a great case study in this. And then finally, who is responsible for all of this? You might have heard the quote that data science, or data is the new oil. So if that's the case, does that mean that data scientists are the new oil field workers? When I talk to some of my colleagues, some of my data science colleagues, they say that they spend around 80 to 90% of their time just doing all of the drudgery, like getting the data from different teams, normalizing it, joining it, and all of this even before they start working on the actual algorithms. So you also have to take that into account. So that's data. Next is organizational chasm. And I'm just looking at the time over here. I think we have about 10 more minutes, so I want to quickly wrap this up. So within organization, there are a few different aspects you need to take into consideration. The first one is the org design. So let's go through that. So when you're thinking of creating your data science teams, or machine learning teams, there are a few different ways you can do that. The first one is business intelligence. In this model, the data scientists are kind of producing reports and presentations, and they are tracking the key business metrics. If there are any time trending in the negative direction, they kind of take note of that and then work with the respective teams to identify what's the root cause. The benefit of this is that it provides a holistic view for the business. And oftentimes, it's also a stepping stone for companies to use data science and machine learning, because in today's times, especially, most companies have a team working on business intelligence and analytics, and they only have the infrastructure for the data, and they have the pipelines to get the data, and the data would be cleaned. So layering in data science and machine learning is a great stepping stone. One of the drawbacks for this model is that sometimes the data scientists and machine learning engineers can feel underutilized because they might think that they're producing reports and presentations, but not actual code. Another model for creating your data science and ML teams is Center of Excellence, or the COE model. This is sort of research-oriented, where the team is prototyping big bets. One of the benefits is that it provides focus and autonomy to the teams because they're working on these massive projects. But one of the downsides is that, or the drawbacks is that, they could be out of touch with what are the day-to-day needs of the business. There might be teams that are kind of stuck needing the day-to-day requirements for machine learning, whereas you have the COE, which is working on long-term visionary projects. It's also costly to set up the COE because it requires staffing not just the data scientists and machine learning engineers, but also the supporting staff. And sometimes when the COE is offering services to other teams, they can act as a resource constraint. And then we have the embedded product teams, which is in which case the machine learning engineers and the data scientists are embedded in the teams itself, in the product teams itself. The benefit is that it provides provides the team with autonomy because they're not dependent on any third-party resource or any team that's outside of them, and they have all the skill set within their team itself. The drawback is that it introduces management complexity because now, let's say, there's one machine learning, there's one engineering manager. Oh, sorry about that. Looks like I lost my presentation. Let me share again. Sorry about that. The perks of presenting online. Please from start. Okay. Sorry, looks like I'm having some technical difficulties. Okay, there you go. Allow. Yeah. Sorry about that. I was trying to, I'm pretty sure I pressed the wrong key, but here you go. Yeah. So we're talking about the embedded product teams and the drawbacks over there. One of the issues can be management complexity, where an engineering manager who would traditionally have software engineers now also have data scientists and machine learning engineers under them. So it kind of introduces a skill gap over there. And for the data scientists and machine learning engineers on the team, they might feel a lack of mentorship. So not to say, like, these are not the only kinds of models. A lot of times companies use hybrid models. And of course, like, this is not an exhaustive list by any means, but these are some of the ones that I have encountered. Now, I'm sure you must be wondering, like, which one of these works best for you? So the answer to that is, you have to determine what works best for your organization. And a thumb rule to remember that is a Conway's law, which states that organizations design systems that mirror their own communication structure. This is something we also realized at Pluralsight very early on, because when I joined the team, we were sort of operating as a center for excellence, but a lot of teams at Pluralsight tend to be autonomous and empowered, and they have the entire team is fully staffed. So we realized like that model was not working, so we pivoted to becoming an embedded product team model. So that's the organization design. The other aspect that we need to consider within this space is the workflows. Oftentimes, AI projects fail to take off because enterprises don't take into account how the AI might adapt, how the existing workflows would need to be adapted to AI. And the good thing is that this is not a new problem. Like, this problem has been around for several decades now. Back in the 1980s, there was a term called the business process reengineering, which was sort of introduced when computers were first entering the market, and businesses were trying to figure out how computers can be part of their day-to-day workflow. So they actually had to take a step back, analyze their workflows, analyze which tasks can be automated using computers, and that's where computers were placed. So this was several decades ago. Over the years, you might have heard terms like digital transformation, which is, again, like a grandchild of business process reengineering. And now we have AI transformation. Now, of course, anytime you hear the term digital transformation, I'm sure it's, you must have also heard of several cartoons and jokes on this. And this is one of them which kind of hits really close to home for me, because in my consulting days, I had heard of a few clients who went through these several month-long ERP implementations only so that they can receive the purchase order in the form of a fax that they can then manually enter in the ERP. Anyway, I digress. So coming back to the workflow, you have to start with, what does your workflow look like? What are the different tasks in the workflow? What are the different decisions that need to be made? And then assess which one of those tasks and decisions can be automated using AI. And let me give you a simple example that we had at Pluralsight. So Pluralsight has a number of different courses, and we produce those courses. So as you can imagine, like, there's several steps involved in producing courses. But one of those steps is there's one unlucky human being in the content authoring department who has to go in and manually assign tags to the different courses. And this is a very cumbersome process that's prone to errors. Like the spreadsheet has about 7,000 rows and several hundreds of columns. And this individual has to go in and manually assign the tags to the courses. The reason it's important is because the search and discovery engine on our platform then uses these tags to surface the relevant content to the user. So over the past few months, we've been kind of working on a project where we are using AI and ML to actually come up with the tags. And now this individual is responsible for validating the tags as opposed to assigning them. So that kind of changes the workflow. But as you can imagine, it also changes the skill set, because now this individual is, previously where they were kind of basing it off of intuition, now they have to work with a probabilistic system, which might be giving output in the form of like, course ID 13 has a tag of data professional and with a 70% confidence score. So this individual now has to deal with probabilistic system, which kind of is a great segue to the next chasm, which is skills. So I don't need to beat this to death over here, but I'm sure you must have heard about the importance of skills for AI technologies. And just to understand or help you understand the scope of this, according to a study done by Accenture in 2018, G20 countries are at the risk of foregoing up to 11 trillion in GDP growth if they don't invest in skill building for AI technologies. That's massive. And when I talk about the AI and ML skills, it's not just the data science or the machine learning engineering skills, but it's also the secondary skills that in my previous example, where this individual who has to work with AI and ML systems, even they need to be upskilled on how to work with these systems. That's where Pluralsight comes in. So just a quick pitch about what Pluralsight does. So Pluralsight is a technology skills platform, and we provide you the clarity to lead along with the skills you need to move faster. In today's times, a lot of CIOs and CTOs are sort of flying blind because they don't have a quantified representation of the skill set of their company. And Pluralsight provides a way to index the skill set of your entire organization, and you can upskill your employees into modern roles, and then you can mobilize your teams to continuously delivering value. We work with over 1,500 of the world's foremost experts to create content, and then our Iris AI and ML platform personalizes your learning journey and the skill development journey across the platform. So as I wrap up this session, I want to kind of close out with revisiting the technology curve that I was talking about. When you are just starting off with your AI project, it probably makes sense to start off small, have a small team working in a lab setting where you have the data. And then as you grow, you need to think about how to cross the chasm. You need to think about how does AI and ML align with your business strategy? How does it, do you have the data and the challenges? So you kind of need to go through all the things that we talked about. So with that, I've come to the end of my talk. Thank you so much. And I should be around for Q&A.
Oh, well, fantastic. Prateek, this is Joel in Geneva. And to those who learned so much as I did on this fascinating overview, to you and your colleagues working globally, I know that what you said really echoed here in Geneva, where people that we know are using AI at the World Health Organization, at the Red Cross, but often we do have lowest common denominators, whether in the UK they're using Excel, or we're seeing faxes, the CDC may be using faxes. So I think we really do need to look at that holistic use of technology. Your comment about capacity building is the last mile. We need to, and those secondary skills really rang true to what we do at the CIO level for humanitarian response. We at PDC, we use AI, we use the cloud, and of course we learn from all the innovations that you relayed. So Prateek, thank you. And to those who want to keep